The discoveries that change the world.
For centuries, physics maintained a strict division between two features of the world. On one side was tangible matter, objects that can be weighed and handled. On the other was energy, invisible forces like heat or light that cause objects to move. The assumption was that these two things never crossed over. Energy was thought to have no mass, and matter was not believed to be capable of turning into pure energy. To study these interactions, researchers use a closed system. This is an isolated environment where no outside forces interfere with the objects inside. This diagram shows a schematic of a closed mechanical system. While the internal parts move around, the crosshair representing the system's center of mass remains locked in place. In an isolated system, the center of mass cannot shift unless an external force acts on it. This law of momentum conservation is a foundational rule of physics. If a scenario were to break it, our current understanding of how the physical world functions would be invalid. Albert Einstein tested the limits of these rules through thought experiments, using logic to interrogate the behavior of the universe. In 1906, he proposed a specific problem: a pristine, isolated box floating stationary in the vacuum of space. Inside the container, a device on the left wall fires a single burst of energy, a photon, toward the right wall. Because light carries momentum, the act of firing the photon forward forces the box to recoil to the left to balance the movement. When the photon strikes the right wall, it transfers its momentum back to the box. The box stops moving immediately. This creates a paradox. The box has shifted to the left, but no outside force ever touched it. This means the center of mass moved, which contradicts the law of conservation. Resolving this requires a rigorous mathematical audit of every variable in the system. The momentum of the photon is its energy divided by the speed of light. P equals E over c. The recoiling box's momentum is its mass multiplied by its velocity. P equals mv. To conserve momentum, these two values must be equal. The time this interaction takes is the box's length divided by the speed of light. By combining that time with the recoil velocity, we can solve for the exact distance the box moved. But even with the variables accounted for, the problem remains. The center of mass has shifted without an external cause. Albert Einstein concluded that the center of mass did not actually move. Instead, he realized that the photon itself must be carrying something more than just energy. The only way to keep the center of mass stationary is if the photon carries a mass equivalent from one side of the box to the other. Assigning a theoretical mass m to the photon traveling length L, its mass times distance equals the box's mass times recoil distance. Substituting our energy variables, the equation becomes ml equals EL over c squared. Canceling L, m is isolated. The result is mass equals energy divided by the speed of light squared. Rearranged, we get E equals mc². Energy has mass. This equation is a rule that applies to every object in the universe. It means that whenever energy is added to a system, that system gains mass. For example, a wound-up spring weighs more than a relaxed spring because of the potential energy stored in its compressed bonds. This principle applies to heat as well. As these metal atoms vibrate and radiate thermal energy, the object becomes more massive than it was when it was cold. Kinetic energy also adds mass. The Earth is more massive because of the energy generated by its rotation. We do not observe these changes in daily life because the speed of light squared is a vast number. It takes an enormous amount of energy to produce a gain in mass that we can measure. The scale of the equation becomes clear when we look at the process in reverse, converting mass back into energy. This is the foundation of nuclear fission. Inside these massive containment domes, the mass of an atomic nucleus is broken apart to release the energy that was holding it together. Because the multiplier in the equation is so large, a tiny amount of mass corresponds to a massive amount of energy. In a nuclear explosion, the energy released is the result of converting just 1 gram of matter into heat and radiation. E equals mc² serves as the accounting ledger for the universe, proving that matter and energy are simply different forms of the same thing.